Greetings all, this is Combustion Reaction Practice Part 2. Let's look over our problem. Citric acid is composed of only carbon, hydrogen, and oxygen. When a 0.5 gram sample of citric acid was burned, it produced 0.6871 grams of carbon dioxide and 0.1874 grams of water. The molar mass of the compound is 192 grams per mole. What are the empirical and molecular formulas of citric acid? Part of this information we're going to use now, part of this information we're going to use later, so let's not have it distract us. So let's start off by taking our mass of carbon dioxide and converting it into carbon. So 0.6871 grams of CO2. And the first thing that I want to do is convert to moles. So we know that 44 grams of CO2 is equal to 1 mole of CO2. And then we want to get from moles of CO2 to moles of just carbon. So in every 1 mole of CO2, we have 1 mole of carbon. And then the last step of what I want to do is go from moles of carbon into grams of carbon. So I know that there are 12 grams of carbon in every 1 mole of carbon. Let's check our units. Grams of CO2 cancels grams of CO2. Moles of CO2 cancels moles of CO2. Moles of carbon cancels moles of carbon, and I'm left with grams of carbon. So if I do this, my final answer going out 4 significant figures is going to be 0.1874 grams of carbon. That's a good starting point. Now let's look at our mass of water. So for our mass of water, we have 0.1874 grams of H2O. And just like in the top one, where I wanted to get from grams of CO2 to grams of carbon, here I want to get from grams of water into grams of hydrogen. So the first thing we do, convert to moles. So 18 grams of water is equal to 1 mole of water. So that's always the first thing we're going to do. Then, the most important step, we know that for every 1 mole of water, we're going to have 2 moles of hydrogen, which is great. Now we need to go from moles to mass. So for every 1 mole of hydrogen, we have 1 gram of hydrogen. And like before, we're going to check our units. Grams of water cancels grams of water. Moles of water cancels moles of water. Moles of hydrogen cancels moles of hydrogen. And if I work this out, I get for an answer 0.0208 grams of hydrogen. Now, like I warned you before, don't just say, oh, happiness, I'm going to find the empirical formula. No, don't forget the oxygen. It might not always be there, but you have to read slowly and carefully. And literally, that is why they gave you a whole gram sample. So my total mass of this particular compound is 0.5000 grams of sample. And I'm going to subtract out my carbon. So 0.1874 grams of carbon. I'm going to subtract out my hydrogen, 0.0208 grams of hydrogen. And finally, I'm going to end up with my mass of oxygen. So if I subtract all those out, I'm going to get 0.2918 grams of oxygen. And there you go, people. I have the 3 important things that I need. My mass of carbon, my mass of hydrogen, and my mass of oxygen. I can take these 3 numbers now and find the empirical formula. Okay, now I have my mass of carbon, mass of hydrogen, and mass of oxygen that I found from the information given prior. My next step is going to be converting all these masses into moles. So I know that the atomic mass of carbon is 12 grams of carbon for every 1 mole of carbon. And then I'm going to do the same thing, find my moles of hydrogen. So 1 mole of hydrogen is equal to 1 gram of hydrogen. And then finally, 1 mole of oxygen is equal to 16 grams of oxygen. Fine. So how many moles of carbon do I have? Well, if I work this out, I get 0.01562 moles of carbon. For my hydrogen, I get 0.0208 moles of hydrogen. And finally, at the end, I get 0.01824 moles of oxygen. I need to look over these 3 numbers and say to myself, which one's the smallest one? And you might need to take your time. I don't care how smart you are. If you read too fast, you're going to make a mistake. So I look at these 3 numbers and I say, oh look, that's the smallest number. So I'm going to divide all my other numbers, including this one, by 0.01562. 0.01562, and finally 0.01562. Okay, so now what do I get for each of these? Well, for the top number, I'm going to get 1. And for the next number, I get something annoying. I get 1.33. And then for the last number, I get something even more annoying, 1.17. And you might be saying to yourself, well, those aren't whole numbers. I thought you were supposed to get whole numbers. And in some cases, you are supposed to get whole numbers. But in some cases, you don't. So you have to work with the data that you find and work with it enough to get a whole number. So I'm going to take all of these numbers and I'm going to say, all right, out of these 2, I have to do something to get it to be a whole number. So this 0.33, I know I can get rid of that. I can get rid of that by multiplying everything here by 3. So if I multiply everything here by 3, I'll get 3, I'll get 4, and finally I'll get another 3.5. Now you might be saying, well, couldn't I just ignore this 1.17 and just round it down to 1? Well, you could. You'd be wrong, but you could, because now, since I multiplied everything by 3, I'm almost there. But I have this 3.5. So what do I need to multiply all these numbers again by to get rid of this 3.5? If you said 2, you're right. So now I'm going to multiply everything again here by 2. So this is going to be 6, this is going to be 8, and this is going to be 7. So remember, these numbers represent the subscripts on my empirical formula. So my empirical formula here is going to be C6H8O7, because like I said in a previous example, this 6 here is going to be the subscript for carbon, this 8 here is going to be the subscript for hydrogen, and this 7 here is going to be the subscript for oxygen, and I'm just going to list them in that order. Now, we've used a lot of the information up here except for the very end where it says the molar mass, the mass of 1 mole of the compound is 192 grams per mole. What are the empirical and molecular formulas of citric acid? Well, this right here, this is an empirical formula. Just going to write empirical formula. There, it's an empirical formula. What I need to do in order to get the molecular formula is I need to start out by finding the empirical mass of this. So if I add together 6 carbons, 8 hydrogens, and 7 oxygens, turns out I get 192 grams. So now that we have this empirical mass, how does that relate to the molar mass? Well, the molar mass that they give you, so we're just going to write molar mass, which is the same thing here as molecular mass. Molar mass, 192 grams per mole. Grams per mole. Because these two are equal to each other, it basically says the empirical formula is also the molecular formula. So the empirical formula and the molecular formula are exactly the same because the empirical mass equals the molecular mass. And we'll look at some more examples of this where they're not the same in a moment.